Hello everyone, today I am solving this problem binary tree right side view. In this problem, suppose that you are viewing this tree from the right side and what are the nodes or what are the value of the nodes which are visible from top to bottom. So suppose that this is the node of the first level, node 1 and node with value 1 actually, and yes, this will be visible from the right. Now, is this node 2 will be visible or not? The answer is no, this won't be visible. The reason is that this node 3 is actually going to obstruct the view of this node 2. So this node won't be visible. Next, let us come to this node. Now, is this node is going to be visible? The answer is yes, because there is no more node on the right side of this node. And now let us move on to the next node, which is node 4, and this node won't be visible. Again, let us move to the right, that is to the next node, and this node is 5. Now, will this node be visible? The answer is true, because there is no node on the right which can actually obstruct its view, and therefore this node will be visible. So from top to bottom, if we see those nodes or consider those nodes which are visible are 1 and then 3 and then 5. So this vector or this array is our answer. So the problem is very simple. Now let us try to understand how we can solve this problem. Well, there are two ways to actually solve this problem. One is by using depth first search and another is by using breadth first search. So let us first try to understand how this problem can be solved using depth first search. So the first thing I am going to do is definitely have an empty vector or an empty array which is going to be the answer. So suppose that this is the space for our answer for our array, and initially its size is 0 because there is no value in this array. And now let us start. The first thing I am required is to know the level of the current node, and definitely I'll start my search from the root node, which is this node in this case, and its level is, let us say, 1. That is, I'm starting the level from 1, not from 0. This is level 3 and this is level 2 and this is level 1. So currently what is the size of the array? The size is 0, which is less than current level, which is 1, and therefore I am sure that no node on this level, well, there is only one node in this case, but if there were many, then no node on this level is actually considered as the first value for our answer. So what I am going to do is to actually write 1 here, that is, this will be the first element of my answer array. Then this is the crucial part to solve this problem actually, that I'll first move or I'll apply recursion firstly on the right side of this tree and then on the left. So first we move to the right and secondly we move to the left, and definitely we increase the level by 1 also. So at this point the level is 2 and at this point the level is 2 as well. So now we are at level 2 and the size of the array is 1, and this basically tells me that currently no node of this level is considered to be the rightmost node of this level, which is true, and this is the reason why I am first moving to the right. Suppose you move to the left first and you realize that no node for this level is considered, then you are bound to use this. This is not correct because there is any other node which is on the right side of this node, and therefore from the current node you are first going to move to the right. So when you come to this node you realize that the size of the array is only 1 and currently you are at level 2 and 1 is less than 2 and therefore you need an answer, so you store the next value which is 3. And now this node has no more children and therefore it's time to actually move here. Now when you are at this node you see that its level is 2 and currently there are already 2 elements present in the answer array, and therefore you know this that some node on this level is actually considered. So again you move to left and right. First you will move to the right side and you will increase the level by 1, so it becomes 3, and then secondly you will move to the left and here the level is 3 as well. Now as you move to the right, first you see there is this value 5 here and the size of the array is currently 2, which is less than the level, and therefore you will store the value of this node in our vector or array. So here we have 5 and then we'll come out of this and then we'll move again to the left, and when we move to the left we see that currently the level is 3 and the size of our array is also 3, therefore there is some node on this level which is already considered. and that node is definitely at the right of our current node, and therefore we won't be considering this node. So finally this thing 135 is our answer, as there are no further nodes to search to. And yes, that's it for this method of DFS. And now let us look at the other method, which is BFS. So in BFS, I am going to consider every node of each level one by one. That is, first I will start by looking all the nodes of level 1, and then I'll look all the nodes of level 2, and then all the nodes of level 3, and whatever is the rightmost node of current level is going to be my answer. So to do this, I'll need a queue which will have one, that is the root node, and then I'll start iterating. I'll pop this node, and currently I'm talking about the first level. So in my answer I'll simply push 1, and definitely I'll include, as I've popped already this node, so this node is not more here, but we have its child. The first child is 2 and the second child is 3. Now in the next iteration I am going to pop all the current nodes of this level. So first I'll pop 2 and I'll insert its child. So I'll pop 2 and I'll insert its child, that is 4 and then 5. Now I'll pop 3, which is the last node of our current level. So now we don't have this here, and as this is the last node, I know that this needs to be included in the answer, so I'll write 3. And then from this queue I'll again start popping. First I'll pop 4, but as this level has more nodes, and therefore I'm not going to use this value 4 as the answer. And finally I'll pop the last value 5, and as this is actually the last node of current level, I can safely write 5 here. You will understand this method better when we'll actually write the solution. So yes, that's it for this method of BFS. So this is how both the methods are applied, and now it's time to actually code these methods one by one. So let us first start by coding DFS. So the first thing I need is definitely a method, and I'll call this method DFS, and this method will actually return nothing. So void DFS, and firstly it will have the current node. Let us call this node as current. The second thing is going to be the present level, and that's it. And other than these things, I'll also need a vector which will become my answer, vector int answer. Now if current node is null, that is, I have reached a node which is non-existent, in that case I am simply going to return. And if that is not the case, then I am actually going to see if answer.size is less than current level, and if this thing is true, then I am going to push the value of the current node inside the answer. Finally, as I told you that first we need to move to the right, and therefore I'll apply another DFS on the right subtree, and I'll increase the level by 1, and then I'll apply DFS to the left subtree. So I actually need to apply DFS at root, and initially the level is level 1. Finally I'll have answer array filled or answer vector filled, and then I'll return this. Accepted. Accepted. Okay, so now let us use the other method, that is, let us solve this problem using BFS. So again I need a vector of integers for answer and a queue which will actually hold pointer to tree node to apply breadth first search. And if root is not equals to null, only in that case I am going to push root inside our queue, and while queue is not empty, till then what I am going to do, firstly I'll have a variable sz, let us call this size, which is equal to size of queue minus 1, and while size is actually positive, let us have another pointer current which is equal to q dot front and q dot pop. Now if current of left is not equal to null, then I'm going to push current of left inside the queue, and similarly if the right node of current node is not null, in that case also I'm going to push the right node. So I'll keep on doing this. Now there's the thing, if our queue actually had 3 elements, that is the current level has 3 elements, then 2 elements are already popped, and as I am first pushing the left element and then the right element, and therefore I am sure that the last element is actually the rightmost element of the current level. So all I am required to do is to push the value of the current element inside our answer. So answer dot push back value of current element, and that's it. So yes, finally I'll return answer. Now let us run this code. Wrong answer. Let us see what's the mistake I have committed. I have queue, I have root, I am pushing root, and yes, so the mistake is this, that I need to do these two things here as well, because initially when the size of the current level is 1, which is true for the root node and it can also be true for other levels as well, in that case I this current has this node, and then I definitely push its value, but I actually forgot to push its children in the queue. So now let us run the code again. Accepted. Accepted. So that's how you can solve this problem, and I hope you like the video, and I'll see you in the next one. Thank you.